Okay, this is lesson 5 talking about radicals. So square roots are all positive numbers that have two square roots, a positive one and a negative. The positive is always called the principal, and that's what we look for. So if I said to you the square root of 25, I'm looking for positive 5. However, if I want the negative of that answer, I would put a negative out front. However, we do know that two negatives will multiply to give us a positive underneath. But if they want the negative one, they're going to show it out front of the sign. So it says the square roots of perfect squares are rational numbers. So that means they could be a fraction or could be a decimal, but they're going to terminate. So for example, if I go square root 0.25, I'm going to get 0.5. Okay, so you can still do square roots of decimals. It does work. And that's what it means by the answers will be possible rational numbers. So they could be whole numbers or they're going to be rational numbers. There it is. Okay, so they're showing us that it says the square root of a perfect square are rational numbers. We just discussed why. They can be decimals, fractions, any kind of digit, or they can just be a whole number or a natural number. They're showing us that square root 16 is only the positive 4. Like I showed you over here, if they want the negative, they will put the negative out front. And that's what they're showing you here with the 17 as well. If they want the negative answer, they're going to put the negative sign out front. Cube roots are a little different though, and we discussed that last time, that with cube roots, and it comes to the difference of something being two-dimensional and something being three-dimensional. Perfect squares and square roots are two-dimensional. Cube roots are three-dimensional. So what that's talking about is it means you need three numbers, all identical, to create your answer. Whereas with square roots, we need two identical numbers to create our answer. So for this guy here, I would have 5 times 5 gives me my 25. Negative 5 times negative 5 would also give me positive 25. Okay? When you're working with cube roots, however, it's going to take three numbers. Negative 3 times negative 3 times negative 3 is going to give us our negative 27. So the cube root says there's three numbers that are identical that are creating my answer. So if I said I wanted the cube root of that answer, this is telling me I want the number negative 3. Cube roots are allowed to have the negatives underneath. And the reason they're allowed to have the negatives underneath is because each digit can contain the negative. Whereas with the other guys over here, two negatives will always multiply to give us a positive. So if they want the negative answer, they have to show it out front. That's the difference, because there's not enough digits to create a negative. And you have to have identical numbers. So you can't have one that's positive and then one that's negative. They have to be identical, either both positive, both negative. Well, in this case, we could have three of them negative or three of them positive. In this case, I would have 10 times 10 times 10, and that's going to give me my 1,000. And then if I want the cube root of 1,000, that's going to give me 10. That tells me that the number 10 was multiplied 3 times. Okay, it was multiplied by itself 3 times. All right, then we get non-perfect cubes. So this one is showing us a non-perfect cube. Those will show up as irrational numbers. So that's what we're talking about. Same thing with non-perfect squares. Those are going to give us irrational numbers, the non-perfect squares and non-perfect cubes, which means they'll give us a run-on decimal. They will never be put into fractions. So let's take a look at other square roots and other types of roots. So the ones we deal with mainly are the perfect squares and perfect cubes. So the square root and the cube root. But you need to know how to create bigger ones on your calculator. So here we've got 2 identical factors. Here we've got 3 identical factors. Here we've got 4 identical factors. And on this one, 1, 2, 3, 4, 5, 6. 6 identical factors. So this is the number of identical, come on, I-C-A-L, identical factors. So 2 4s, 3 5s, 4 2s. So we would say the square root of 16 is 4. So in words, they're saying root 16 equals 4. So the cube root of 125 would be the 5. When it's asking for cube root or square root, it's asking for the original number that was multiplied. Which original number was multiplied 3 times? Or in the next case, 4 times. So what number was multiplied 4 times by itself? The number 2. So the fourth root of 16 is 2. Now on our calculators, we know how to bring up square root and cube root. For a square root, we're going to hit second x squared. Those are the buttons we got to hit for a square root. That's glitchy. Hang on. So we get x squared. Then if I want cube root, I'm going to hit math 4. So I hit the math button and then number 4 and then enter. That'll bring up my cube root sign. Then I need to know how to bring up a 6th root or a 7th root or a 10th root. That means we have to insert the index. So we have to insert index first. So the index number first. So on our calculators, if I want the 4th root of 16, I'm going to type in the number 4. That's my index. Let me grab, I need to borrow a calculator real quick. I hope not. No. So you're going to type the index number 4, then you're going to hit the math button, and then you're going to hit number 5. So number 5 is going to show up with an X root like that. Okay, it's an X root. So that's when you're going to put, then you got to write, it's going to show you where you can type inside it now. And that's where you would type the digits. Okay, so on this one, I would then type 16 and I would get the answer of 2. So everybody give that a try. I want you to type the index of 4. So type 4, math, 5, and then type your digits, 16. So 4, math, 5, and then type in 16, enter. Okay, so 4, math, 5, 16, enter. What? You should get 2, yep. You should get 2 because we're doing 4th root of 16. Okay? So whenever you want to put a different index in, you've got to use the math 5. Math 5 will always put in, it's this X one. It looks like an X where the index goes. That's why you got to type the index number first. Okay, we're going to practice typing in some of those on the bottom now. So if I go square root 49, we know the answer is positive 7. If I wanted the answer negative 7, they would have put a negative sign in front. The next one is a cube root, so it's allowed to have a negative underneath, and it's saying negative 64. So I'm going to grab my calculator, and I'm going to go math 4, negative 64, enter. So math 4, negative 64, enter. And that'll give you the answer, negative 4. Okay, now we're doing a 4th root of 10,000. So again, if you want 4th root, if it's a power of 10, just count the number of zeros. Well, 4th root means there needs to be 4 zeros under there. So what number did they use that multiplied to give you 4 zeros? 10. So this guy, if you tried to figure him out, would be 10. So what you would type in is 4, math, 5, 10,000, enter. That's how you'd actually type it in. So math 4, math 5, 10,000, enter. And you'll get 10. Practice typing those numbers on your calculator, please. Now, what if it's a fraction? Well, if it's a fraction, you put it in brackets. That's the only difference. So when you enter it, you're going to put the inside in brackets. Some calculators automatically do that, some do not. So you have to put the brackets where there's fractions. So for this one, I'm going to go 5, math, 5. That's going to put my fifth root in. That's what this is doing. Then I'm going to type bracket 1 divide 32, close my bracket, enter. That's how you have to type that one in. And you should get 1 over. Yep, right. And now if you go math, enter, enter, you should get 1/2. It should be 1 over 2. Okay? So you should get 1 over 2, which is 0.5. You could use the decimal because it's a terminating one. That's fine. Sometimes yes, sometimes no. Actually, if it's a quiz or a test, look at what the multiple choice answers want. And if it's not multiple choice, the question will tell you whether it wants a rounded decimal or whether it wants the fraction. Okay? All right, good question though. Now we're going to try typing these guys in, and I want you to see what the answers could be. So we're going to all try typing in 4. So you have to hit on this one. You've got to go math 4. Nope. 4 math 5, pardon me. So 4 math 5 negative 16, enter. Make sure you use that negative button at the bottom, not the subtract button. So use that negative button. It's by your equals, usually. So everybody should get an error for this question. This question should not work. Did everybody get an error? Yep. Good. Is it because it's negative? Yes. So this question is going to give us error. And it's all because of this nasty negative sign underneath. Under a square root sign, we're not allowed to have a negative sign because it's an even index. Whenever you've got an even numbered index, so 2, 4, 6, 8, you can never have a negative underneath the root sign. But if it's an odd number, 3, 5, 7, you can have a negative number underneath. So we're going to make that note. So even number indexes cannot have a negative. Whoa, that's glitchy. Cannot have a negative sign under the root. And the root is called a radical sign, just so you know. Okay, so even indexes can never have a negative underneath. They will always give you an error. Okay. Now, an odd index, they can have negatives underneath, but not the even ones. So the next one, we have to type in kind of funny because we've got the number 2 out front. And whenever we've got something sitting side by side, that means multiply. So in your calculator, this is going to come up as 2 times. And now we need the cube root sign. Well, that's math 4. And then you're going to type in 1, 2, 5, enter. So you should get 10. This should give you an answer of 10. Because the cube root of 125 is 5, and you're timesing it by 2. 2 times 5 is 10. So just like I said, if you take this little part first, if you just take the cube root of that number, you're going to get a 5. Then you're multiplying it by 2. All right, turn your page. So now we're talking about what to use on the calculator again, and this is showing you your calculator steps on the next page. So it says using the X root. The X root, this is where we have to put in our calculators. So they're showing us the calculator steps. Whoops. Okay, those are the calculator steps. So if we want the 4th root of 10,000, we would first type in the 4, then we press the math button, then we hit the 5, then we type in our digit 10,000, then we press enter. So these are all the steps on what to do exactly in your calculator if you don't remember. So now what I want you to do, I'm going to give you a couple minutes. I want you to solve the ones on the next 2 sections here. I want you to see if you can solve those. The biggest thing you need to remember is wherever there's a fraction, they need brackets. So fractions will always need brackets. Okay, I want you to give a try solving those 4 and then the next 3. And then I'll put them up. It may take a shorter. Okay, so check your work and make sure you got the exact same numbers. Again, like I said, look for the ones in scientific notation. Okay, that guy was in scientific notation. Okay, now we're talking about what an actual radical looks like. So a radical has 3 different parts. It's got the root sign. Okay, so this is our basic root sign. That's called the radical sign. Then it's got an index part. The index part is right here. The index sits in that little check mark. It's like a little check mark. If you don't see an index, that is the only time the number 2 can hide. So if you don't see one, it's a 2. Otherwise, they have to show you every number bigger. Now, there'll never be with a 1 in there. There'll never be a root sign with an index of 1. So we will write index of 1 doesn't exist. It's impossible. Because we need a minimum of 2 numbers to create an answer, not just 1 number. Alrighty. So a whole radical, you've got 3 parts. The index, the radical sign, and the part that's underneath now. The part that's underneath is called the radicand. Okay? And then like I said, you've got your index out front, the little small guy, and then you've got your root sign. So our actual radical sign. Okay, so 3 parts to a radical. Let's take a look at the next page real quick. So we're just going to identify the parts. So what are the different parts of radicals? Okay, the index. Let's go through all indexes. The indexes are always what's hiding in the check mark. So it's that little number right there. Whoa. Erase that. That was crazy. So this little guy right there and that little guy right there. So our indexes, if it's hiding, like the number on B, it's a 2. Okay, and then a 3. Now we want the radicand. That's the number underneath. So the number underneath in this case is 75. In this case, it's a 50. And in the last one, it's a -1/10. If it's a fraction, the negative will always sit with the top number. Okay, this guy's written with the negative right beside and almost with the bottom number. They will always float to the top, just so you know. All right, let's take a look at a couple different processes. Let's see if multiplying and adding and subtracting, we get the same answers. So if I take and I multiply or divide, so if I've got root 9, how big is the square root of 9? 3, good. How big is the square root of 4? 2, good. So what is 3 times 2? 6. So that means my answer should be 6. Well, what is 9 times 4? 36. So this is actually the square root of 36, which gives us 6. So we're saying the left side is equal to the right side. Is it a true statement? We would say yes, this is a true statement. We say the left is equal to the right. Absolutely. Okay, so that is a true statement. The same is going to happen for dividing. If you're dividing, it will also be a true statement. So multiplying and dividing work. But let's look at adding and subtracting. So if I take the square root of 9 again, I get 3. Square root of 4, I get 2. Well, if I add them, I'm going to get a 5. And if I go square root 13, which is what that becomes, it is not equal to 5. So that means it's not possible when you've got adding and subtracting to do it together under the root sign. If you've got adding and subtracting, they have to be done separately. That's what this is showing us. And the same thing will happen with our subtraction. If I go 3 subtract 2, I get 1. But here, root 9 subtract 4 is 5, and the square root of 5 is not equal to, to 1. It is not equal to 1. So for adding and subtracting, you have to do them separately. Multiplying and dividing, yes, you can solve them and you'll get the correct answer. So that's basically what these two things are telling us. If it says product quotient and product quotient, that means the timesing and dividing. That's all that's saying. And then when it says sum and difference, this means you're adding and subtracting. Okay, so those guys have to be done separately. Okay, so add and subtract must be done separately. Alrighty, so that's where they're showing us the generic statements. So now they're going to tell us a generic statement. The square root of A times the square root of B, multiply A and B, you get your answer. Absolutely. So when you're timesing them, you can basically sit them side by side under the root sign. Okay? Whereas dividing, same thing. You can put it all underneath as a fraction. So if you see a fraction, that means it's being divided. Okay? And here you would use brackets if it's a fraction under your root sign. Now, one thing we have to write down that we haven't written down yet is BEDMAS. In BEDMAS, root signs behave like brackets, which means you must solve them first. And that's what we need to remember. So, radical signs behave like brackets in BEDMAS. So they are solved first. So they solve first. Okay. Those solve first. All right, so now we're going to take a look and we're going to see if these are true or false statements. So if I go 3 times 6, do I get 18? Yes, I do. So this guy is true. Remember, your timesing and dividing they basically go together. So if I go 20, divide 10, what do I get with 20 divide 10? 2. So this guy works. True. We're not taking away root signs. We're just seeing if the digits will multiply or divide. Now, if I go 9 plus 16, what do I get? 25. So that means I would get square root 25, which equals 5. Whereas over here, I'm going to get 4 plus 3 is 7. So this guy is false because these are not equal. The left side and the right side are not equal. That's our big thing that we have to remember. when we're trying to do it. Left side, right side, not equal. All right, the last few on this page. 8 times 3, what's that going to give us? 24. So we're going to put square root 24. 7 times 3, 21. Under the root sign, it stays. Does 50 divide by 10 without giving me a decimal? You betcha. I get a 5. And he stays under his root sign. They don't lose their root signs. Now I need to do a double root. So this guy's going to be, what is this? You have to do the inner root first, this one first. So what is the square root of 100? 10. So the top then becomes, the outer root is still there. So the outer blue root is still there, but now the pink part I solved and got a 10. And now I'm dividing that by the bottom. So we're dividing by root 2. Does 10 divide by 2 evenly? Yes, it does. So we will divide it evenly and get root 5. Okay, so that's a true statement. Oh, we don't need to tell if it's true or false. We did, though. Okay, last one on here, 77. We have last 3 examples. So square root of 77. Oh, what can I break that into? What would multiply to give me a 77?
11.
And 7. Good. So this guy would break down into square root 11 times square root 7. 11 times 7. So it's almost like we're prime factoring, but now we're bringing down what the multiples were, what multiplied to give me that big number. So what do you think multiplied to give me a 27?
3 and
9 and 3, good. What about 40? What do you think multiplied to give me a 40? 4 and 10, good. 4 and 10. And that's what we're going to be working on in the next lesson, is being able to break them down. So we get root 9 times root 3, root 4 times root 10. You have to show those time signs because it's saying that's what's giving you the product up top. That is the end of lesson 5. Tomorrow we're going to break these down and go converting mixed to entires.
So is that simple?
It is. So you've got about 20 minutes, well, no, about 10 to 15 to finish working on these questions in the assignment. So number 2 to 13. You should be able to work on 1 to 13, actually. All right, this ends lesson 5.